Good evening, class. Today we're going to be looking at circumference and arc length. This is the one that we will split into 2 days because it is a little bit tougher. But to find circumference, it is technically a new equation. I think we dealt with it just briefly. But the way we find circumference is this. There's actually 2 different ways to find it. And that's because we know the relationship between the diameter and the radius. So, one thing to add over here is maybe put circumference for a formula we need to know. C equals pi times diameter, or C equals 2 pi r. Now it officially reads, the circumference of a circle is C equals pi d, or C equals 2 pi r, where d is the diameter and r is the radius. So if I look at the circle below, well, I could do it as C equals pi times 12, or I could have it as C equals 2 times pi times r, or 6. Either way, I would find the same circumference. Let's look at how to do this. There's a whole lot of problems here. Let's look at just the ones on the left first. Find the circumference is what I'm trying to tell you to do for 1, 2, and 3. And for 4, 5, and 6, I'm asking you to find the radius. So, in the first 3 problems, it says the diameter of a circle is 5 centimeters. Well, they don't give me a circle, so let's quickly draw one. So, I have a circle. They said the diameter is 5 centimeters. Wait, the diameter is 5 centimeters? I'm looking for circumference, so circumference is equal to pi times d. Oh, so circumference equals pi times 5 centimeters. Now, if they do not specify, 5 pi centimeters is good enough answer for me. But if they say round, you have to be able to punch it into your calculator. For us, the pi symbol is right here on the calculator. So in this case, all I'd have to do is 5 pi, enter. And my answer would have been C equals 15.7, and round to the appropriate place. I would do 1 here, centimeters. Either answer works. Listen to the problem. If it doesn't say, I'd prefer 5 pi. If it's a word problem, yeah, probably 15.71. Depends on the situation. Alright, so this one they're still looking for circumference. And the red ones, they are looking for the radius. Alright, so if I look, circumference of a circle, I have 2 pi r or pi d for my options. I'm given the radius, so C equals 2 pi r makes more sense. So C equals 2 pi times 7 inches. So C equals 14 pi inches squared. So again, depending on the problem, I'm fine with that. If it's a word problem, yeah, plug it into a calculator. If it's something that says round to this spot, yeah, calculator time. Because it's more of a real scenario and you're probably going to be using more of an exact answer. 43.98 inches. Alright, the next one. Circumference equals... Am I given the diameter? Am I given the radius? Oh, I am given the diameter. Look, if I would draw a dotted line here, that would also be perpendicular to the top and bottom. Well, that'd be a rectangle. So this has to be 12 feet. So I know the diameter has to be 12 feet. So pi times the diameter, 12 feet. So C equals 12 pi feet, or C equals whatever 12 pi is in the calculator, 37.70 feet. Again, depending on the situation. I honestly prefer 12 pi. If it's just a normal, like, find this. But if it's a problem that says, what's the length of this, or what's the circumference of the circle, and it's a word problem, yeah, probably going to be the adjustment form. Alright, that's how we find circumference. Again, you write down your formula, you plug in what you know, and you solve to find what you don't. Well, what about the cases where I have the radius? So 4, 5, and 6 over here. Well, 4 was a word problem, and it read Well, it's not really a word problem. It just said the circumference is 8 pi. Find the radius. Oh, the circumference is 8 pi. And they want me to find the radius. It makes most sense that for each of these, I'm going to use c equals 2 pi r. C equals 2 pi r. C equals 2 pi r. And at this point, I just plug one I know. I know the circumference is 8 pi. So 8 pi equals 2 pi r. Solving for r, I want to get by itself. It's multiplied by 2 pi, so let's divide both sides by 2 pi. If I divide both sides by 2 pi, r has to equal, well, 8 divided by 2 is 4. And the pi's cancel out. Let's look at the next one. They tell me the circumference is 16 pi. So again, plug in what I know. The circumference is 16 pi equals 2 pi r. Divide both sides by 2 pi. The pi's cancel out. 16 divided by 2 is 8. Alright, doesn't look too bad. Let's do the next one. Plug 26 in for circumference equals 2 pi r. Divide both sides by 2 pi. And I look and 26 divided by 2 is 13, but pi doesn't cross out this time. So how do I get rid of pi, or how do I enter that? Well, I just take 13 divided by pi and enter, and I get 4.14. Pi doesn't always cancel out. It just happens whenever the circumference is 16 pi or 8 pi, it's nice to us. Whenever it's not, we actually have to figure it out. Alright, that's real quick how to find the circumference. And honestly, this is where I would normally stop, I believe, for the first day. With the exception of finding something in a word problem. But this is pretty much it. This would have been the first part of chapter 4. Sorry, chapter 11, section 4. So now we're going to look at one last problem before we're going to look at the stuff for the second part of section 4. So it says the radius of a car tire is 21 inches. Sounds important, let's write it down. Radius is 21 inches. If the car drives 5,280 feet, how many revolutions does the car tire experience? Alright, the car traveled 5,280 feet. Wait, unless this car did a burnout with the tire squealing, the distance it traveled and the length along the edge of the tire would have been the same. So 5,280 feet, well, let's convert that to inches. There's 12 inches in a foot. So if there was 2 feet, there would have been 24, 2 times 12. If there was 3 feet, there would have been 36, 3 times 12. So I'm going to take 5,280 times 12 inches, and I'll get 63,360 inches is how far it went. Well, what's the circumference of the tire itself? Because that would be the length of one time around, which would be one revolution. So if I know the length of one revolution, and I know the total length it went, I should be able to find how many revolutions it took. So the circumference is 2 pi r. So the circumference here would end up being 2 pi times 21. So 131 point, and this one I'm going to go a little bit further. 9,469 inches. So each time the tire goes around once, the car has gone 131.9469 inches. We know that it went a total length of 63,360 inches. So, if that's the total length of wind, and this is the length per one, if I take the total and divide it by this, I should get how many times the tire had to spin around. Basically, I'm going to divide by this because I want to subtract it. I want to repeat subtraction. If I subtract 1 from this, 132 from this, over here, that would be 1 revolution. If I do it again, that would be 2 revolutions. If I do it again, 3 revolutions. Repeated subtraction is division. So I want to take 63,360 inches and divide by 131.9469 inches. And I get 480.19. So how many revolutions does the car tire experience? The car tire has spun around 480 times in 5,280 feet. And there we go. A little bit of a tougher example, but we should be able to handle that. All right. Now we're looking at what would be part 2. Now we're not looking at the full circle anymore. We're going to be looking at the slice of a circle. So like a slice of pie or a slice of pizza. We're no longer looking at just that little part of it. We're looking at, sorry, not the whole thing. We're looking at just a little part of it. And arc length is the actual length along the edge of a circle. So if I would draw a circle up here, here's my roughly drawn circle. The arc length would be a portion of it. So for instance, if I were to look at just this part right here, along the edge, from here to here, so this shaded region, this, if I actually told you the length of it, how long that was, like as if it was a piece of string, how long is that piece of string? That is what we call arc length. The measure of that arc would be the measure of the central angle. So for instance, if this was 160 degrees, that's the measure. But if I was talking about the arc length, it might be 12 feet. So arc measure is different than arc length. Arc length is the actual length that's measured in meters, feet, inches. Arc measure is measured in degrees, and that's the degree of the central angle. So here's the corollary. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of its arc to 360. Whoa. Ratio equals ratio. This is a proportion. So I'm going to set up a proportion. And in this proportion, I'm going to do part of the circle to the whole circle. I'm going to set it equal to part of the circle to the whole circle. And I'm going to compare 2 different things. First thing I'm going to measure, compare, is the measure of the arc. So the measure of this part here, of this arc, would be, for instance, 160 degrees. So let's do measure of arc AB. So measure of arc AB. In this case, it would be 160 degrees. To the full circle, 360 degrees, equals the length of arc AB, or arc length of arc AB. In this case, I know it was 12 feet. And that will be equal to the full circumference. We're going to use 2 pi r. 2 pi r. So this would be 2 pi times whatever the radius is. And that's how we set up a problem like this. We're going to compare the measure of the part to the measure of the full. So like 160 to 360. Then we're going to compare it to the length of the part, the arc length, to the length of the whole, 2 pi r. So this is just a really fancy way of setting up proportions again. But it's used to find the slice of pizza, that part, that portion of the pizza, or the pie. This would end up being a big portion. This length is going to be proportional to the measure. So let's try using this a few times. Find the indicated measurement. So I have 2 circles here. And I have a whole bunch of different pieces of information in it. I say, for instance, 90 degrees, 8 feet, so on and so forth. And they want you to find the measure of everything here. Alright, I realized I forgot to mark something on my circles here. But this arc and this arc are congruent. Arc BA and arc AC are congruent arcs. Alright, so the first part here, we're just trying to find the measures of everything. So, if this is 90 degrees here, a right angle, the remainder has to be 360 minus 90. So 360 minus 90 would be 270. And if these two arcs are congruent, that means their measures are congruent. So that means if the total arc is 270, each arc is half of that, or 135. So this arc is 135 degrees, and this arc over here is 135 degrees in measure. Alright, so I found all the measures over here. Now I look, circle F over here, the center is F. But wait, so that means this over here has to be 180 degrees because it's a half circle, semicircle. If this is 180, this is 30, those two add up to be 210, and 360 is the full amount of the circle, so if I take 210 from 360, I get 150 degrees. So that tells me that this angle right here is 150 degrees. Oh, so I found all the measures. So now when they ask me for the measures, it's just going to be to identify where they are. Measure of arc BAC. So the measure of the big arc is 270 degrees. 135 plus 135, or it's 90 taken away from 360. Measure of arc BA is 135 degrees. Arc BA, 135. Measure of arc EG, 150. Again, this is a chapter 10 problem, so I'm not going to, these four were just review, so I'm not going to go into too much detail. Measure of arc GHF. GHF. Well, I don't see an F anywhere, so somebody made a mistake. I meant E. Measure of arc GHE. So arc GH is 30, arc H, the semicircle is 180, so 180 plus 30 is 210. Alright, so we've gotten the measure of the arcs out of the way. Now it's time to apply the new stuff, which is to find the actual lengths. And if I look here, whenever I'm doing arc length, I need to set up the proportion. Part to whole, part to whole. And I've never actually put the formula over here. So arc length. So I know I'm going to be using that formula. So for number 5 here, they want me to find length of arc BAC. So if I look at my formula, that means I'm putting an X over here. Arc length AB, arc length BAC, I'm going to use X. The circumference is 2 pi r. 2 pi times the radius of the circle. BAC is this one over here. So the radius of the circle is 8 feet. The measure of arc BAC I already found. 270. And that's over the full circle. So let's just make sure I did this right. What I'm looking for is the arc length BAC. I compared it to the full circumference, 2 pi r. The part of the circle, that's its measure, is 270 degrees. The full circle, 360. At this point, I've set up my proportion correctly. Time to cross multiply and solve. You could also reduce this over here first. And honestly, I probably would. 3 to 4 equals x. And let's reduce the bottom part over here. 2 times 8 is 16 pi feet. Alright, so cross multiply now. 4x equals 48 pi feet. Divide both sides by 4. I get x to be 12 pi feet. So, up here, the length of arc is 12 pi feet. I'm going to skip down and do number 7. Let's find the length of arc AC. So again, I'm looking at the circle. Again, proportion. The part of the arc for this, arc AC, is right here. The portion that is accounted for is 135 degrees out of 360. The length of arc is x out to the full circle, 2 pi r. or 8 feet. Oh, and now I'm looking for the length of arc AC. Time to cross multiply and solve. Let's reduce the right side first. It ends up being 3/8 equals x to 16 pi again, feet. Cross multiply. I get 48 pi feet equals 8x. Let's move this up where I can write a little bit easier. Divide both sides by 8. X equals 6 pi. And there we go. We found two arc lengths. So again, we're setting proportion. Part of our circle to the whole. Part of the circle to the whole. And we look at the degrees first, then we look at their actual lengths, and we're comparing degrees to lengths. For the last two here, I thought I'd give us a little bit more room to solve these problems. I'm looking for the length of arc GH. So again, set up your proportion. Part of the circle that arc GH accounts for. 30 degrees out of a total of 360 that I could have accounted for. The part that I'm looking for, the length x here, compared to the full circle. 2 pi r. 2 pi, well, if the diameter is 24, the radius is 12 feet. So 2 pi times 12 feet. Let's simplify a little bit. 1/12 equals x over 24 pi feet. Cross multiply, 12x equals 24 pi feet. Divide both sides by 12, x equals 2 pi feet. So the actual length of arc GH is 2 pi feet. Again, if you want to be punching these into the calculator instead of using pi, go ahead. For instance, this would be something real close to 37, 38. This would be real close to 6.2, 6.3. This is going to be real close to 18 or 19 feet. All right, go ahead and attempt the last one on your own. If you set it up correctly, you should have gotten 150 degrees, part for arc EG, to 360 equals x to, or y or z or whatever variable you end up using. So the full circle, 2 pi times 12 feet. If you got the setup good, if you didn't, try and watch the last one actually. I think this one would end up being the easiest one to follow. Number 6, which would have been the one I just did. But yeah, if you got it, no, you don't see me. Reduce the left side to make it easier on ourselves. I believe we end up getting 5/12 equals x to 24 pi feet. Cross multiply, I get 12x equals something pi feet. 120 pi feet. Divide both sides by 12, x equals 10 pi feet. So the length of arc EG is 10 pi feet. And if you put that one in decimal form, you would have got 31.4 feet. All right, and there we go. This is how you find arc length. I know I did a whole bunch of examples here. This one was the clearest on explaining why. This one was next because you could actually see what I was doing. All right. Now let's look at a word problem. All right, we're looking at an outdoor track. We know it's 400 feet long. So if I drew a track, something like this, and I knew that there was a straight part and a straight part over here. And that both of these parts over here were semicircles. So there was a radius here from the center, R. There's a radius here from the center, R. They tell me that it's 400 meters long. So the full length is 400 meters. And they tell me that each of the straight parts here is 100 meters long. What does the radius of those circles have to be in order for this track to officially be 400 meters long? Well, if that's 100 and that's 100, and this is the same as this semicircle over here, that means this arc out here has to be 100 meters. This has to be 100 meters. So if I'm looking for the radius at the two ends, well, this is supposed to be a semicircle. That's supposed to be a semicircle. Oh, so it's not a full circle, and I'm using arc length, the length along the edge of the circle. Well, the measure of a semicircle is 180 degrees. Which is what this is. It's 180 degrees because it's a semicircle. The full circle is 360 degrees. The length of the arc is 100 meters. Compared to the full length of the circle would be 2 pi r, but I don't know what r is. Oh wait, look at this. This is basically just a solve. I'm looking for r. I use the arc length formula, measure of the semicircle to the full circle, equals the length of the arc to the full length of the circle. And at this point, it's just simplify. So 1/2 equals 100 to 2 pi r. Cross multiply, I get 2 pi r to be equal to 200. Divide both sides by 2 pi. R is equal to 2, well, it ends up being 100 divided by pi. And at this point, it's time for a calculator. So the radius of the track, if done correctly, would have to be 31.83 meters. And there we go. So again, for section 2, or part 2, you're going to be doing a lot of proportions again. You're going to do the part to the whole, part to the whole. That's all I have for you today. Till next time.